So in today's lesson, we're going to be continuing our conversation with arithmetic and geometric sequences. The primary focus will be geometric sequences. In our last class, as we worked through some of these problems, the question sometimes arises, why are we doing this and how does this get used? And we'll ever see this again? And so today you're going to be looking at a lot of application problems that use geometric sequences as a way of getting to an answer involving loans, for example, or mortgages, credit cards. Those are all examples of how a geometric sequence might be used. But to be able to do those problems, you have to be able to, first of all, change percentages in the decimal numbers. If you don't recall how to do that, then the first step would be, this is one approach. First step would be to change the percent into a fraction. And percent means an amount out of 100. So I would be taking 22 and I would be dividing it by 100. And you will find a calculator to be extremely helpful in today's lesson. So please use the calculator on the It's Learning page. Would be a perfect calculator to use today. 22 divided by 100, the decimal number is 0.22. Even if you have a decimal number, so 12.5%, and if I want to turn that into a decimal number, I'll do the same thing. I'll take 12.5 and I will divide it by 100. So the decimal number becomes 0.125. So take a look at the remaining problems. Think about the steps you have to go through. There are some patterns, but the one way that will always work is take the number divided by 100. Please convert all of these into decimal numbers and then turn the video back on when you're finished. When you turn the video back on, all you will see will be the answers. With the exception maybe one or two of these problems, there will be no additional explanation given other than what's already been done for the first two problems. So all the answers are provided here. Just keep in mind that we always divide by 100. 100% is one of those that when students see the number 1, it kind of stop and look at thinking, is that right? But it is 100 divided by 100, which is 1. Same thing with 200%. It's 200 divided by 100, which is the reason why it's 2. If the percent is more than 100, expect the decimal number to be greater than 1. If the percent is less than 100, then expect the decimal number to be less than 1. There are two kinds of interest problems that you're going to be looking at in this lesson. One is called simple interest problems. And again, as you have me see a percent, we're going to be turning that percent into a decimal number. So the difference between a simple interest problem and a compound interest problem is that a simple interest problem is actually an arithmetic sequence, which we're basically trying to figure out what number are we going to be adding, and we're going to add the same number over and over again to get to the next answer. So if I had a $750 CD, I got 4% interest for the year.
Reggie McLaurin.
So if you had a 4% annual interest and the investments were $750, 1 year later, how much interest would Sam get? And that's going to be the amount that we're going to be adding each time to get to the next answer. So why don't you go ahead and figure that out. Turn the video back on when you're ready to check your answer, and then we'll move on to the next problem. So the 0 year is $750. And basically you are getting 4 cents for every dollar. So if you invested $2, you're going to get 8 cents at the end of the year. If you invested $10, you're going to get 40 cents at the end of the year. So to get the actual answer, we take the 750, we're going to multiply it by 4% as a decimal number, which is 0.04. And what it would end up with is $30. So that means that year 1, the CD is now worth $780. At year 2, we're going to add another $30, so we're at $810, and then continue again to get the next answers by continuing to add 30 each time. So at year 5, the CD is now worth $900. So the next problem, Sabrina decides she wants to borrow $5,000 from her grandparents. She will use the money as a down payment on the house. Her grandparents are charging her 8% interest, simple interest for 2 years. How much will she owe her grandparents at the end of the loan? So go ahead and think about the problem we just completed. How we determine the amount to add each time. In this case, it was $30 each time. Try to apply that same idea to this problem here, and when you have the answer figured out, go ahead and turn the video back on. So Sabrina gets $8,000. She's going to be basically paying her grandparents 8 cents for every dollar. So for $2, that would be 16 cents. For $3, it would be 24 cents, and so on. And the reason why it's 8 cents is because if I convert 8% into a decimal number, I'm going to take 8 divided by 100 and I end up with 0.08, which is 8 cents. So if I take 5,000 and multiply by 0.08, the answer would hopefully came up with is 400. So that means that she's going to pay $400 every year to her grandparents until the loan's paid off. Since it's only for 2 years, at year 0, the loan's for $5,000. At the end of 1 year, if Sabrina decided to pay it back early, she would owe her grandparents $5,400, since that's the amount of interest being charged each year. So if she went ahead and decided to go the full 2 years, she would owe her grandparents $5,800. So simple interest problems, again, are arithmetic sequence problems. We're adding the same number over and over again. Now this type of problem is probably going to be the one you're going to see most frequently in lesson 1-3 and even, 1-2 and even in 1-3. It's trying to come up with not only the geometric sequence, but also the R value, which we talked about 2 days ago, identifying as a growth and decay, and really the new thing that's going to be in this lesson and the next is the percent of change. So U of 1 is 20. And then to finish off the equation for the recursive formula, we're trying to figure out the number we're multiplying by every time over and over again to get to the next answer. Now I'm going to talk about this a couple of different ways because sometimes it's really easy to figure out. And in this case here, this is definitely a little bit easier than some of the other problems you're going to see. But you basically take the second answer and you divide it by the first answer. And that is our multiplier, which is 2. If I take A divided by 40, I should also get the same answer. So if this is truly a geometric sequence, I should get basically the same answer. And what I mean by basically is that sometimes we have application problems where we're rounding to a certain place value, and what we may find out is that the R value are approximations, and they may be slightly off, but they shouldn't be off by very much. In this case here, they're all 2s. So that's the number that we are multiplying by over and over again to get to the next answer. And that number we're multiplying by is actually the R value. R stands for common ratio. Now clearly this problem is a growth since the answers are going up. Now for a percent of change, what you do is you take the R value and you multiply it by 100. The reason why we're doing that is that we're converting the R value back into a percent. So on the first screen, we started with a percent and turned it into an R value by basically dividing by 100. So now we're going to multiply by 100 to turn the R value back into a percent. To find the percent of change, it's basically 2 steps. You take the R value as a percent, which is 200%, and you're going to subtract 100% from it. Now the 100% that you're subtracting, this is what you're always doing. And you're always starting with the R value as a percent. So 200% minus 100%, and the answer is 100%. That is the percent of change. It's a 100% change, and it's a growth. That's which we circled this here. So sometimes the percent of change will be a decay, and we'll get to one of those soon here, so you can see what the difference is going to be. But 200, our R value is percent minus 100. That answer is the percent of change. So the second problem, if you would go ahead and think about the steps we just went through and see if you can figure out all the answers to this, including the percent of change. Turn the video back on when you are ready to continue. One of the things I found with students as they worked on these problems is that they really didn't want to actually calculate the R value. They're just trying to figure out what that number is. I would suggest, like in the problem above, that you turn it into ratios. Second answer divided by the first, third answer divided by the second, fourth divided by the third, and make sure that you're getting the same answer each time. So if I take 25 and divide it by 10, that's going to be my R value. So the R value is 2.5. You need to check to make sure that's consistent. So if I take 62, which is the third answer, 62.5, sorry, divided by 25, you get 2.5 again. So we'll save a little bit of time here. If I take the fourth answer divided by the third answer, I'm also going to get 2.5 again. So the R value is consistent. U of 1 is 10, and U of n equals U of n minus 1, and we're multiplying by 2.5, which again is the R value, which means common ratio. The answer is going up, so again we have a growth problem. To find the percent of change, hopefully you remember to take the 2.5 and multiply it by 100. Percent, and that's going to give me 250%. To find the percent of change, you take the R value as a percent, which is 250%. You subtract away 100% from it. Again, you always subtract away 100%, because 100% is really no change. So anything above 100% is a positive percent of change. Anything below 100% is going to give you a negative answer, actually, and that's going to tell you that you have a decay or a decline in terms of the answers you're going down. So in this case here, the percent of change is going to be 150%. Because it's positive, that means, again, like we indicate here, it's a growth. So the next problem, you're going to do the same thing. There are 4 problems here. And so in class, my other class, we went through problem B together, and then assigned A, C, and D to be completed in class. And if they weren't finished by end of class, then they became homework. So why don't you go ahead and see if there's what the R value is. Write the recursive formula, growth, decay, and can you determine the percent of change. And when you're ready to continue, turn the video back. So if you hit the 29.375 and you divide it by the 73.4375, it actually comes out to be a really nice number, 0.4. And if you take the 11.75 and divide it by the 29.375, also get 0.4 again. And if you check the 4.7 divided by this, the 1.88 divided by the 4.7, and all 4 problems, the answer ends up being 0.4. So this has a consistent ratio. You may find that some of these may be a 0.4, like a 0.399, and maybe the next one's 0.401. It's really close to 0.4, but a slight difference, and that may be because the numbers themselves are being rounded. But we're going to accept that the R value is going to be 0.4, even though the numbers may be off just a little bit. You may see that especially on problem C. But U of 1 is 73.4375. That is the first answer. We're multiplying by our R value, which is 0.4.